uses Ezouidi theorem to solve the 11-degree equation. So, hello, how are you? How are you doing? I wish that everyone is okay. This is, let's say, Mourad Sultan Ezouidi. This is Mourad Sultan Ezouidi. Today we are going to solve the 11-degree from the equation. Okay. So we have, let's start my professors, my colleagues, and my teachers, and my learners, students, and kids. Today we have the honor to explore a groundbreaking advancement in the field of algebra presented by Professor Mourad Sultan Ezouidi, a mathematician whose deep research in polynomial equation has led to powerful new method of solution, contrary to the classical conclusion of the Abel theorem, which states that there is no general solution biological for problem of degree 5 or higher. Professor Ezouidi introduced the novel theoretical framework that allows the exact solution of specific high-degree problem equation, including those of degree 11 and beyond. Using what's known as Ezouidi theorem, we approach the following 11-degree polynomial equation, which is equal to x raised to the power 11. I will just, first of all, I'm going to share, sorry, I should share, let's say, the, yes, I should share this with you. Okay, share this with you. So that will be, so that you can join the lecture and get benefit, Okay, so this is Mourad Sultan Ezouidi, the pioneers and methods with you now is handling with them 11-degree from equation. That's hard, in fact, to solve it. Really method. Okay, you will see that it's very, very easy to uh, uh, to solve 11-degree from the equation. Okay, so we start. This is our 11-degree from the equation. So just see if the if I was live or not, first of all, and then okay, I check YouTube channel, then okay, so now it works. Yes. Okay, so we can say that this is our proof to the power 11. So 11 raised to the power 11, x raised to the power 11 minus 33 x raised to the power 10 plus 495 x raised to the power 9 minus 4,455 x raised to the power 8 plus 26,730 x raised to the power 7 minus 112,266. Okay. 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 So you can see the coefficient of this 11-degree from the equation. Okay. And we call that plus 336. Okay, 336,798 x raised to the power 5 minus 721,710 x raised to the power 4 plus 1,082,565 x cubed minus exponential 5I pi divided by 101, the square of x, minus between parentheses negative 5,845,851 plus 6 times exponential 5I pi divided by 101 all times x plus 9,565,938 minus 9 exponential 5I pi divided by 100. So this is our 11th degree polynomial equation. Okay, it's a defies challenge. Okay, so me, Mourad, the Professor Mourad Sultan is really explains how to solve these original degree polynomial equation using his theorem. Okay, and the theorem is that if you want to dive into the structure, you'll see the theorem. This is my theorem, my first theorem. Okay, so which is subscript s subscript k minus one of order s subscript k minus one of order q equals the sum from zero r equal from 0 to k, the combination of n minus r to k minus r, n raised to the power r between parentheses, negative and 0 of order q, all raised to the power k minus r times n r minus 1 of order q. Okay, this is, we call, is our theorem. Now we are going to set k equal 0 and set k equal 1 and set k equal 2 and set k equal 3 and set k equal 4 and also put k equal 5 and put k equal 6 and put k equal 8, 7, 8 and 9 up to 10 to find all the coefficients of my new original 11 degree from equation. Okay, now we'll figure it out after. So let's now figure out, let's say, the value of s minus 1. It's very easy here, my learners. S minus 1 is going to be equal to 1. Okay, this is by convention. Okay, according to my theorem. Okay. Okay. So prepare your calculators, your paper sheets, write your 11 degree from the equation, and follow the steps of the Professor Mourad Sultan, and you will understand how it works and how you will get, let's say, exact roots in front of your eyes, and these exact roots will be touchable. You can touch the exact roots. Okay, so here we thought that I want to find s0. S0 here, my learners, is going to be equal to a null, simply because the formula stands that s0 is equal to n minus n times n0 42. Now let's dive into the structure when putting k equal to obtain s1. So just substitution and make your expansion of this structure or of this theorem, and you will find that S0 is equal to negative 633 plus 363, which is equal to what? Which is equal to an O. Okay, now we continue. Let's dive into the structure and set k equal 2 in order to find S1. S1 will give you exactly the correct coefficient of your 11 degree from the equation. You don't have another pathway. Okay, you should apply this theorem and you will figure out, let's say, the coefficient of this new 11 degree from the equation. After that, you are going to write this 11 degree from the equation, and you will make your our notes, okay, about this 11 degree from the equation. You can see that some coefficients are complex numbers and the other aren't. Okay, so here in this example, we calculated the value of S2 according to Mr. Mourad Sultan Ezouidi, according to his formula. We obtain that S1 is equal to 0. Okay, just substitution and do your best. Then we should calculate also S, S, S2. In order to get S2, just dive into the structure and put k equal 3, and after that you will make your own substitution and you will see that s2 in fact is equal to 0. Okay, let's wait for Microsoft to work. Okay, Microsoft itself, I gave this example to Microsoft. He raised your hands and he did nothing. Okay, and let's say my method is let's say a powerful method because it's will light, let's say, what was before light shadow. Okay, so we told that this is S2. We put k equal 3 in the decimal formula of Mourad Sultan Ezouidi, and we obtain that this is the value of the general formula of S2, okay, which is equal to, okay, I'm still waiting. Okay, prepare your notes as I told. Okay, we told let's dive into the structure. Every term speaks. Every coefficient has a message, and the Zwede method knows how to listen. And you, my learners, my professors, you should also know how to listen to this new theorem, this new method. Okay, that is, let's say, that is not like the classical method that failed in error. Okay, and that we give, let's say, uh, roots, approximated roots, which in fact is not real roots. Okay, so what seems impossible by tradition becomes with Mourad Sultan is really clear and exact. We using my method of course. So this is S2. We thought that S2 is equal to 0. Just make your own substitution. I will find that is equal to a no. We continue. We'll find, let's say, S3. In order to find S3, just dive into the structure and put K equal 4 to get S3. So this is the formula of the fourth coefficient of new 11 degree from equation. That it's very simple to now to substitute n with 11, n with 33, and 1 with 495, and 2 with 4455, and 3 with 26,730, and we will find this is equal to a no. Okay, so we continue the procedure. We continue calculating S4 and S5 and S6 and S7, and you will see that these values are equal to 0 except S8, which is different to 0. Okay, S9 is going to be equal to 0 and S10 equal to 0, and you will see that here you will use all the coefficients when let's say when when you want to find S10. So here we told that S3 is equal to 0. Now I'm going to find S4. To find S4 is very easy. Just dive into the structure or dive into the theorem of Mourad Sultan Ezouidi and put K equal 5. After that, you will see this is the formula of S4. Okay, that is written in terms of the highest power and the coefficient of this original from the equation. After that, we are going to make substitution, and you will get that the value of S4 is equal to 0. Okay, we continue the procedure, and we want to find now what exactly to find S5. To find S5, my kids, just go step by step. Dive into the theorem of Mourad Sultan Ezouidi and put K equals 6. Okay, and between parentheses, travel wheresoever. Okay, even if you want to travel to the moon, you will never find this formula. Okay, so this is my theorem that has been developed and discovered and innovated after more than 14 years of work, of thinking, of sleeping a while and getting up to write, let's say, formula, to write or to start discovering. Okay, so discovery is not easy. Those who would like to be a researcher, you haven't got the ability to sleep. Okay, because if you want to be a sleep man, so means I were lazy. Okay, and you are busy. Okay, so me, Murat Sultan Ezouidi, the professor, is here to explain what others uh, close the door. Murad reopen. Murad Sultan really open this door. Okay? In other words, Abel's close this door. Mr. Murad Sultan really open it and make, let's say, bright into um, into a shadow. Okay, so here we told that I'm going to find S5. This is the formula that will give you the sixth coefficient of your new level equation that started from L0 for the Q up to L5 for the Q, and is going to be the highest power. Make your own substitution, and you'll find that S5 is really equal to 0. Okay, and you can see that it's let's say each coefficient has a message. Okay, every step in this theorem uh, speaks. Okay, and the Ezouidi method, or the method of Ezouidi, knows how to listen. And you, professors, teachers, colleagues, and learners, you should know how to listen. To listen, not only to listen. Okay, that doesn't mean listen. No, means how the formula works. Okay, so now we calculated, let's say, the value of, we call the value of S6 using the last formula that has been written in its lowest term. Okay, this one. And we found this is S5. Okay, we found that S5 here is equal to a no. We continue the procedure and you will see the value of S7. What is S6? Sorry, the value of S6. S6 will give you the seventh coefficient of your new 11 degree from equation that corresponds to the original 11 degree from equation, and then make conclusion or find the x-roots of this new 11 degree from equation, and after that making the relationship, let's say, that deals with alpha subscript k from 0 to 9, yes, to 8, sorry, equal to 0 for the q plus the x-roots of this new from equation all over the highest power of your original from equation. We'll see this after, okay? So we can say that this method is not only powerful, or this theorem is not only powerful, it's a new chapter in the story of mathematics. It's a new chapter in the story of mastering the solution of nth linear degree equation and mastering the solution of nth degree polynomial equation. Of course, using Mourad Sultan Ezouidi theorem. Okay, and here this example is gonna be addressed to those who have smart minds, those who are still believing that impossible, that there is nothing impossible. Everything is possible in this universe, but you should think and deep and think deeply, okay, inside every from the equation. Okay, so we are not rounding here, roots, okay, or we aren't revealing. Sorry, we aren't rounding roots, but we are revealing. So this is in fact is not just one equation. This is in fact is not just about one equation. Okay, so it's about a strategy, a method, pathway, a way, a light. Okay, that will bright what was once shadow. Okay, so now we continue. We told that I'm going to find a six. Just this is the formula that will give you the seventh coefficient. Make our substitution and then find the c is equal to 0. Now we continue. I want now to dive into the structure to get S7. Just put k equal 8. Okay, in the theorem. Okay, or in the formula, whatsoever, and we can see that after using Mourad Sultan Ezouidi theorem, we'll state that S7 is equal to negative 7, or negative combination 7 choose 1 times combination 11 choose 8 times L0 42 to the power 8 plus combination 9 choose 6 L to the power 2 times L0 42 to the power 6 times L1 42 minus combination 8 choose 5 L to the power 3 times L0 42 raised to the power 5 times L2 plus combination 7 choose 4 N raised to the power 4 times L0 for the q raised to the power 4 times L3 for the q minus combination 6 is 3 and raised to the power 5 times and 0.42 raised to the power 3 times and 4 of 22 plus combination 5 is 2 and raised to the power 6 times and 0.2 squared times and 5.2 minus combination 4 to 1 times and raised to the power 7 times and 0.2 raised to the power 1 times and 6 upon 2 plus and raised to the power 8 times and 7.2. You can see this formula of a 7 depends on only L0 up to L7. Okay, you stop at 1,801,082,565. Okay, because the last term here is L7. This formula has been generalized from the theorem of Mourad Sultan Ezouidi after making the expansion or finding the value of the binomial coefficient, okay, and making, let's say, a 0 for the q raised to the power 8 as a common factor and make the difference between these two binomial coefficients, this or that, and you will reach to this formula. Okay. After that, make your own substitution, my learners, my professors, and you will get the S7 here, okay, is equal to 0. So, if we compare this method to Abel's theorem or Isaac Newton method or matrix method, this is it's very important and powerful, okay? You can say others where others saw a world in solving such in solving or in mastering the solution of an integral equation. We have covered a doorway. Okay, so we continue. We told I'm going to find a 7. We told that make your own substitution, and you will note that 7 is gonna be equal. A 7 is gonna be equal to 0. Okay, and we conclude that our original 11-degree polynomial equation has a new 11-degree equation that is written in terms of x raised to the power 11 minus k and the coefficient of s subscript k minus 1 over r. So here we call that make your own substitution in this formula. I mean this one, calculate this, you will obtain that is going to be equal to a known. Okay, now I'm going to dive into again my professors into the theorem of Mourad Sultan Ezouidi, and you will write S8 as that with k equal 9, and we will find that S8 in fact is equal to this one. Okay, that started with combination 8 choose 1 times combination n choose 9 as well as 2 raised to the power 9 up to n raised to the power 9 times n 8 to 2. Okay, so apply this formula that will help you to give you that will help you to find the ninth coefficient of our new level-degree polynomial equation relative relative to original level-degree polynomial equation. So here we calculate S8. We found that the value of S8 is in fact is different to another. Okay, you see it's a complex number. Okay, raise it and multiply by 11 raised to the power 9. So which is equal S8 equal negative between parentheses 1,082,565 plus exponential 5 pi divided by 101 all multiplied by 11 raised to the power 9. This is the coefficient of the ninth this is yes, this is the ninth coefficient of our new 11-degree polynomial equation. Okay, now its coefficient each coefficient sorry has a method. Okay, and each, let's say, or every step speaks. So and the method of Mourad Sultan really knows how to listen. And as you, professors and teachers and colleagues and learners and trainers and researchers, those who are looking for solving the equation, you should know how to listen to this formula and to see the behavior of these empirical equation that, let's say, demonstrate that they can be solved using Mourad Sultan theorem. So, Professor Mourad Sultan Ezouidi explains continue explaining uh, how to find the coefficient of this new Newton equation. Okay, and we reach to find now S9 and S10. S9 and here and S10 here, in this example, is going to be equal to 0. As S10 is equal to 0 means that the first root is going to be a 0 divided by 11, means 33 divided by 11, which is 3. Also, S9 equals 0 means also that alpha or the root is going to be equal to a 0 or the two all divided by 11 is going to be means we have a double root. Or in other words, alpha equal 3 equal 33 divided by 11 equal 3 is a root, okay, where 2 is the order of multiplicity, or where 2 is its order of multiplicity. So here we calculate the value of, we obtain the, the formula that will give us, let's say, the 11th coefficient of our new 11 degree from equation, and we make our substitution, and we made our substitution in this formula of Mourad Sultan Ezouidi, okay, and we got the value of S10, which is equal to now, okay. So it's very easy just use your calculators and start uh, making your own conclusion or writing the new 11 different equation regarding to the coefficient value found before. Okay, so we can say that the theorem of Mourad Sultan Ezouidi rewrites what was believed to be a dead end. We bring light into what was once shadow. Repeat again. We we bring light into what once shadow. So this one means what was shadow before. How can we think that there is a new elementary equation corresponding to the original elementary equation? Means its structure or its step speaks itself. Okay, but it looks for smart mind to receive the message. Okay, me, the Professor Mourad Sultan Ezouidi, received the message earlier, and he did his research and he spent more than 14 years of work to establish this new fact that yeah, we can solve any equation. Okay, so this is the calculation, my kids. Just use the calculation. Okay, and you find that the value of S10 in fact is going to be equal to another, equal to 0. This is the structure is in front of you. Just make your own, just make your own calculation, and you will see, you will get the fact that yeah, S10 equal another. S10 equal the now the last option of this new identity equation, means the original identity equation has a root which is very easy to find it. Okay, it means its coefficient send a message. When S10 equals 0 means we get, let's say, alpha equal 33 plus 0 over 11, which is 33 over 11, which is equal to 3. So these now learners, professors, and the students and colleagues, these are the coefficients of these new 11 division equation. You can write your problem to the power 11 as that, x to the power 11 minus s0 for the r, x to the power 10 plus s1 for the r, x to the power n. Sorry, not n, uh, 9 minus s0 for the r, x to the power 8. Okay, so else, yes, plus S3 for the R, x to the power 7 minus S4 for the R, x raised to the power 6 plus S5 for the R, x to the power 5 minus S6 for the R, x raised to the power 4 plus S7 for the R, x cubed minus S8 for the R, the square of x, plus S9 for the R times x minus S7 for the R equal to 0. You see, all the coefficients are equal to 0 except this one. So I'm going to replace S, okay, S9, S10, just a moment. This is S8, not S9, okay? From the back. This is we told S9 is equal to 0, S10 equal to 0. I'll come here. I'll take this one, S8. Where is S8? This is S8. I will take, okay, S8. This one is S8. Stop here, Mr. Mourad. Okay. I'll take this one. Copy. Okay. No, no, no. Okay. Okay, I'll take this. Okay. That. Control D. Okay. This is the value of S8. Don't forget about the negative sign because I took only this. Okay. I will now, because S8 is equal to, is different to 0. Okay. Let's come here and write the value of S8, which is equal to negative. Okay, 1 million. 1 million. Okay, this one. Stop, please. Okay. Okay, this one. Okay. So this one we told stop here. Stop here, please. The S8 is equal to negative control D. Okay. Okay. So it's the same as that. Okay. So here, so no need to do it. I will just do like that. So I will change this is S9. I will change this is S9. Okay. And this one is S8. This is S8. Yes, like that. Okay. So I'm going now to write this here. You can see that our prime to the power 11 has to be written as that. X to the power 11 minus S8 of OD2 x squared equals 0. Means x squared equals 0, or I'm going to change S8 with negative. Between parentheses, 1,082,565 plus exponential 5 I pi divided by 101, all multiplied by 11 raised to the power 9. Okay? Yes. So you see this minus, okay, this one, and this will be positive. Okay, I'm gonna raise this negative 0, 0. Okay. So we got that. Now x9 is equal to, okay, equal to, we thought this is minus, when is S8, this is S8, minus S8, this is minus, will be positive. So here it has to be negative, okay, will be negative. Here will be negative because plus when it will be transferred to the right hand side, it will transfer to the negative sign. Okay. This negative 1, in fact, is negative 1. You can write it as exponential I pi. And this one has to be multiplied by exponential. Okay, I will do it. Exponential. Come here. Where I am. Okay. I will multiply this by, sorry, again. Yes. By exponential 2k I pi. Exponential 2k I pi, which is equal always 1. Exponential 2k I pi. Okay. 5. Not by 5. Okay. So, and this minus, you can write it as exponential I pi. So it will be 2k plus 1 all times I pi. Ignore this line now. So, now if we are going to solve x raised to the power 9 equal this, means you are going to find the 9th root. means you are going to write x sub, of course here x squared equals 0 means x subscript, sorry, x subscript, x subscript 10 and 11 are equal to 0 means you will get a root which is equal to a0 for q raised to the power 11 divided by 11, which is equal to 33 divided by 11 equal to 3. It's a root where 2 is order of multiplicity. Okay, so let's solve this one if possible. Okay, we move to x subscript. Okay, in this one. Okay, x subscript k belongs to what? Belongs, okay, belongs to 10 and 11 because I'm looking for the 11th and the 10th root of this original 11 degree from the equation. And these x subscript means x10 or x11 equal 0. These are called x roots of this new 11 degree from the equation. These also are called x roots of this new 11 degree from the equation. I solved this. So now you see this is 11 raised to the power 11, all raised to the power 1 over 11. It will be 9 divided by 9. It will be 11 raised to the power 1. That's why I wrote it here. The next will be 1,082,565 plus exponential 5 pi over 101, all raised to the power 1 over 9, exponential 2k plus 1 between parentheses times I pi over 9. These are called the axes of this new electric equation. Now, if you want to make conclusion, my learners, it's easy. We solve this new electric equation. What is the next step? The next step is that. And so, one by one, the exact roots of this 11 degrees from the equation stand this, let's say, stand this before us. Means these are the axes of our new 11 degrees from the equation. We are looking for what exactly the question is to solve the 11 degrees from the equation. It's very easy. So, alpha, these are the roots of our original 11 degree from equation. It's labeled as alpha subscript k belongs to 0 to 9. Okay, 0 to 8. 0 to 9, yes. Okay, yes. 0 to 0 to 0 to 8, sorry, 0 to 8. Because different roots here. So it will be L042, means the sum of the roots of the original 11 degree from equation plus the x roots of the new 11 degree from equation that correspond this to the original 11 degree from equation, all divided by the highest power, which is 11. It will be 33 plus this, plus 11 times 1,082,565, plus exponential 5 pi divided by 101, all raised to the power 1 over 9, times exponential 2k plus 1 times I pi, all divided by 9, all divided by what, my learners? By divided, with all divided by 11, the highest power. You can see 33 divided by 11 is 3. 11 divided by 11, it remains only this one. Okay, I'm going to write it now in front of you. So this is not just about one equation. This is about changing how we understand algebra or algebra itself. Okay, so the theorem rewrites what was believed to be a dead end. Okay, and we bring light into what was once shadow. This method is not only powerful; it's a new chapter in the story of mathematics. Okay, so here also here, one by one, the exact roots of this 11 degree from the equation stands before us. Okay, meaning that, let's say, the ninth, the ninth roots respectively are 3 plus 1,000,000 2,565 exponential 5 by 5 divided by 101, all raised to the power 1 over 9, explanation to k plus 1 I pi divided by 9. So, okay, I will just a moment, my learners. I send this to you, the best teacher in Khmer, Habib, the best teacher in Khmer. Okay, so we continue. We told that these are called the roots of what? Of, uh, of, uh, of the original 11-degree equation. Okay, and you remember when we told that x squared equals c. Yes. When we told that x squared equals 0 means x10 equals 0 or x11 equals 0. Okay, or we can make x belongs to 0, 1. Okay, no problem. But I label it as x10 and x11 because this 11 given this new given equation has 11 x. Okay, so alpha now 10 equal 33 plus 0 divided by 11, which is 33 divided by 11, which is equal to 3. We can write it here. It's a root. It's a root. That's a root. It's a root. Okay. Because is a root. You can say that is a root. Well, or we can say it's a W. Or we can say it's a root. It's root. It's a root of order of order of order of order order of multiplicity multiplicity two. Okay, or we can say where 2 is its order of multiplicity. So here we solve this limit to the power 11. You can see here we have only three limits. The other are conjugate terms. Okay, so we have 8 roots and the other three are three roots. Okay, okay. So here, and so next time I'm going to explain an example like that. Okay, this proof in fact not that Abel was wrong because he didn't think of algorithm because he didn't try to invent new theorems that mix with new algorithm equation. But there is more beyond of the game to describe it. Really theorem does not break the rules. It is the deep structure to have done. Thank you for joining. And remember, mathematics still holds sacred, but now hold the key. Okay, let's see this example first. I will see the example around here. This is it, yes. I prefer to do it. I will prepare this example. I started prepared, but I need some time, more time to be like with you, professors and teachers and colleagues, to give you a chance to understand, at least to see how to solve and equation whatsoever, the highest power of the formula equation. Murad's theorem will solve it and will find you at least the coefficient of this new equation. Okay, so in this example, my learners, We see that we can solve it by making x raised to the power 10 plus s4x raised to the power 5 plus k 5 s9. Yes, this one has to be incremented. Okay, we change the coefficient, then I prepared, yes. I stop that here. After finishing this one, I'm going to write the coefficient about. Thank you for listening. I will make it here. Okay, I will make here this like that. Okay, because this so thank you for watching, enjoying the lecture, and goodbye. Thank you. This is Professor Mourad Sultan explaining how to solve very difficult equation without using the classical method that follows factorial equations. Okay? And like so other theorem that states there is no dimension of solid polynomial to the power more than 5. Okay? But we are supposed to be bright light or give light to what was before, or let's say, how to say this, we bring light into what was once a shadow. Okay? Means if you see a shadow, that's not mean life's impossible. When you see a shadow, you can dive into this shadow and swim and suppose that is the same effect. That's what I really gonna do. And goodbye. So, sorry, we'll close this one now. Okay.